question on a velocity time graph, and we've done a lot of work on this already, so this question will really help to hammer home some of the things we've talked about in the past. Okay, so we've got a boy jumping off a wall who lands on the ground without bending his knees, and the graph shown here shows how the velocity of the boy varies with time as he lands, as he hits the ground. And the first question, it asks us what property of a velocity time graph can be used to determine the acceleration, and we've done tons of work on this already, and we know that the gradient of a velocity time graph is what gives us the acceleration. So it's the gradient of a velocity time graph. Now the gradient can be defined as the change in y divided by the change in x, rise over run, if that's how you like to remember it. So change in y divided by change in x, as I've written just here. Now the second part of the question asks us to use the graph to calculate the boy's deceleration and give its unit. So the first thing we need to do is determine the change in y and the change in x, and that can be done very simply by looking at the graph carefully. Now when I answer these questions, I like to use triangles. I think triangles straight away, and I like to use as big a triangle as possible. So looking at this data on this graph, we can do the following. Now I've drawn here a triangle that you can see just about with the red outline here. And as I said, I like to use as big a triangle as possible. So I've decided to use the full data set. So if I look across on the axes, I can find out what my change in y and my change in x is. So on the y-axis, we're going from 0 all the way up to 6. So my change in y must be 6. Similarly, if I do the same on the x-axis, I'm going from 0 all the way to 0.25 seconds. So that means my change in x must be 0.25, as I've written here. So, going back to our expression for gradient, change in x, which is what this triangle symbol means here, delta means change, change in y divided by change in x, we are left with a simple sum of 6 divided by 0.25. And that leaves us with an answer of 24. And as we said in part 1 of this question, the gradient of a velocity time graph gives us the acceleration, and therefore if we have a gradient of 24, that means that the acceleration, or in this case the deceleration, as we see the graph has a negative gradient, the person is going from 6 meters per second to 0, so therefore they must be decelerating or going slower. We have a gradient of 24, and that is equal to our deceleration. So we can write here our deceleration is 24, and the units for deceleration or acceleration are meters per second squared. Meters per second squared. Easy 3 marks. We're then told that the mass of the boy is 70 kilograms, and it asks us to calculate the resultant force in newtons acting on the boy. So we can simply apply Newton's second law here, which is F equals ma, and by substituting our values for mass of 70 and acceleration, which we calculated in the previous question, we have the following: 1680 newtons, 1680 newtons, and that's our answer. Incidentally, had the question said that the forces were balanced on the boy, then the object would obviously not be accelerating. So the fact that there is a deceleration or an acceleration on the object means that there is a net resultant force, meaning that there are unbalanced forces. So we have a net resultant force of 1680 newtons. The last part of the question wants to know why the boy should bend his knees as he lands, and that's simply because we can get the same change in velocity in more time, and therefore there's less deceleration and less force on the boy's knees.